Welcome back to another video. In this video, we are going to talk about how to solve logarithmic equations, okay? A logarithmic equation is an equation that contains a log in it. So it might look something like this: log ax equal b. So it has a log and the variable is inside the log. So that's what makes it a logarithmic equation, if the variable is inside the log. So you might see one that look like this, or you may see a logarithmic equation of this form. Oh, let me write this: f of x log a of g of x. So you have two logs in this case, and in this case you only have one log. So that's important because depending on what the form of the logarithmic equation is will depend on the method that you use to solve it. So if you have one log, then you will solve this one by rewriting it in exponential form. So rewrite equation in exponential form. So remember how to go from logarithmic form to exponential form. This is your base, this is your exponent, and this is what it equals. So this will look like a to the b equal x. And that will help you be able to solve for x. So if this is just x, then x will be solved for. But if you have like some function of x there, then you'll just manipulate that by getting x on the side by itself. So if you have one log, you'll solve it by rewriting the equation in exponential form. If it has two logs, one log on each side, and the bases are the same, so as long as the bases are the same, then you can solve this equation by just setting f of x equal to g of x. Because this implies, that's what that arrow means, this log base a of f of x equal to log base a of g of x implies if these two things are equal, then the f of x has to equal the g of x. And so you will set those arguments equal to each other and then solve for your variable. So this will be the equation that you would solve. Alrighty. So these are the two different ways you will solve logarithmic equations. Now sometimes your logarithmic equation may not be exactly in one of these forms. You may have to use some of your properties of logs to actually combine the logs together to make it be in one of these forms. So we're going to work 3 examples, okay? So we'll go through one of each of these, and then I'll show you one where you have to actually combine them together to put it in one of these forms. So let's jump into some examples. For example 1, we want to solve 7 times the natural log of x equal 28. Now this one has one log, so it looks like that first form that I showed you just previously. However, it has this number in front of the natural log, so I want to get rid of that number in front of the natural log, and then I can solve it how previously mentioned. So this is 7 times natural log of x. So if I want to get rid of 7, then I would do the opposite of multiplication, which is division. So I would divide both sides by 7, and that would tell me that the natural log of x is equal to 4. So now I have one log, and so to solve this, I will rewrite this in this equation in exponential form. So with the natural log, what is my base? So remember, this is the same as saying log base e x equal 4. So my base is e. So this will rewrite as e to the 4th equal to x. So your base raised to this power equals that number. So x is equal to e to the 4th. That would be your answer. That's your exact answer, right? But it might ask you for an approximation, and in order, so x equal e to the 4th is your exact answer, but it might also ask you for an approximation. And so if you need to get an approximation, you would just do the e to the x button, which is right here on your ln button. So second e to the x, and then you'll put in a 4. Anywho, when you put it in, you get 54.59 when you put in e to the 4. 598. So if it asks you to round, then this will be approximately 54.6 if I round it to 1 decimal place. It just depends on what your homework asks you, how far it asks you to round it to. And so this is how you will solve this exponential equation, or not. And this is how you will solve this logarithmic equation. For example 2, we want to solve log base 2 of x to the third minus 19 equal to 3. So this is a logarithmic equation because your variable is inside the log. And so you want to solve this because it only has one log. You want to solve it by rewriting it in exponential form. So to rewrite this in exponential form, the base is 2, the exponent is 3, and then it equals to x to the third minus 19. And then you would just solve this equation. So 2 to the third is 8, x to the third minus 19. Add 19 to both sides to get x on the side by itself. You get 27 is equal to x to the third. And how do you get rid of a third power? You take the third root of both sides. So if you take the third root of x, those count of x to the third, those cancel, that gives you x. And the third root of 27 is 3. All right, that means what number do I raise to the third power to get 3? And that's 3. So one way, so to show you how to do the third root in your calculator, you would go to math. And if you look at number 4, I don't know if you can see it, but number 4 is the third root. And you would do 27. Third root of 27 is equal to 3. Now, if you go back to math, number 5 will allow you to do any root. So a fourth root, a fifth root, but you will have to actually put the number in first. So you will have to put the 4 in first if you wanted to do a fourth root. Or you will put a 5 in first if you want to do a fifth root, and so forth. So this is how you will solve that logarithmic equation. Let's do one more. Okay, for example 3, we want to solve log x plus 6 minus log x plus 2 equal log x. Now, if you notice, we have multiple logs, so this is definitely not that first case where you have one log and you solve it by rewriting it in exponential form. This is going to be the second case where you have a log equal to a log. However, we have more than one log on this side, so this is also a case where you have to use properties of logs to actually combine your logs together. So remember, there's a property of logs that says when you take a log minus another log, you can combine those two logs by actually dividing the arguments. So that was called the quotient rule for logarithms, quotient property for logarithms. So I can actually rewrite this left side as log x plus 6 over x plus 2. And that's by the quotient property. The quotient property allows me to rewrite these by dividing since it was subtraction. If that was a plus sign, then we would combine them by multiplying. That's the product property for logs. Alrighty, now we have where we have a log equal to a log and the bases are the same. There is no base there, which means it's an understood base of 10. So since the logs are the same, then I could just take these arguments and set them equal to each other. So I get x plus 6 over x plus 2 is equal to x. And so now I need to solve for x. So I will solve for x by, since this has a fraction, I want to get rid of this x plus 2 out of the denominator. So I will multiply both sides by x plus 2. And the x plus 2's will cancel and leave me with x plus 6 equal. And when I multiply x by x plus 2, I have to actually distribute the x. And that gives me x squared plus 2x. So it looks like I'm going to end up with a quadratic equation. How do I know it's going to be quadratic? Because the highest exponent is 2. And remember, whenever you deal with a quadratic equation, you need to get 0 on one side. So what that means is that I'm going to move this x over here and I'm going to move the 6 over here. So I'm going to subtract x from both sides and I'm going to subtract 6 from both sides. That'll give me 0 over here. That'll give me x squared plus x minus 6. In order to solve this quadratic equation, we could use any of the methods we've learned about solving quadratic equations: factoring, quadratic formula, completing the square. In this one, you actually can't use the square root property. However, this one looks like it's going to factor really nicely. So if I want to solve this, I need to find factors of -6 that add to 1. So that means two numbers that multiply to give me -6, but add to give me 1. And so off the top of my head, I'm thinking 3 and -2. 3 times -2 is -6, and 3 plus -2 is +1. So this is going to factor into x plus 3, x minus 2. And now I have two things that multiply to give me 0. So So that means I take each of these and set them equal to 0. So x plus 3 equals 0. Subtract 3 from both sides. X equal -3. And x minus 2 equals 0. Add 2 to both sides and you get x equal to 2. Now, there are some restrictions when it comes to solving logarithmic equations, and that is you cannot take the log of a negative number. So whenever I'm solving a logarithmic equation, which I didn't go back in the last one to check, but it wasn't in the last one, I have to go and check these solutions to make sure that it doesn't give me the log of something negative. So for example, it's not that my answers can be negative, it's that when I plug it back in, I can't be taking the log of something negative. So when I take -3 and I plug it in here, I get -3 plus 6, which is a +3. When I take -3 and plug it in here, I get -3 plus 2, which is a -1. And you cannot take log of -1. That means I have to rule out this answer of -3. All right, what about 2? When I plug in 2, I get 2 plus 6, which is 8. That's positive. I get 2 plus 2, which is 4. That's also positive. And then I get log of 2, which is positive. So x equal 2 does not give me the log of anything negative. So that would be my only solution for this problem, x equal 2. Alrighty. So this problem was pretty long. So what did we do? We first combined these two logs by using the quotient rule. Then since we had a log equal to a log with the same base, we took the arguments and set them equal to each other. So the x plus 6 over the x plus 2 equal to x. Then we solved for x. By getting rid of the denominator, multiplying both sides, we ended up with quadratic. So we got 0 on one side. Then we solved our quadratic equation by factoring. Once we got our solutions, we had to go back and plug in our solutions to make sure it didn't give us the log of a negative number. You cannot take the log of a negative number. So whenever you solve logarithmic equations, you want to always go check your answer to make sure it's not giving you the log of a negative number. So this is how you solve. These are a couple examples to show you, or a few examples to show you how to solve logarithmic equations. If anything doesn't make sense, if you have any questions whatsoever, put them in the comments. I promise you I will respond. And hopefully if this video helped you, hopefully it did, please hit the like button. And thank you for tuning in. If you haven't already, please subscribe to my channel. And I will see you in the next video. Thanks for tuning in.